Hello, Tom from Every Step Calculus, EveryStepPhysics.com. Physics problem, as you can see on the screen, it's a question that was submitted to the internet, and they need some help. This Physics AP, Physics C, they can't figure out this question. Any help would be greatly appreciated. Well, now they can go online and they can check and see if they can't find something like this with professors on there, and professors are going to go through a lot of nonsensical words and teach. My programs don't do that. They show you how to do the problem. That's all they want to know right now. And of course you learn quicker by actually being shown how to do the problem than to be the theory, teaching all the theory and stuff, okay? Let's do it. Physics, to get to my main menu. And I'm going to scroll down now. When you buy my programs, in physics it's $30 for almost 400 programs. Tell you everything to know about physics. And you're gonna hold the second button down on your calculator and use this cloverleaf here to go down to the. I have to scroll because of the simulator. And but I can press second and the simulator and down, and it'll go screen by screen, but it's kind of slow, so I just tend to use the cursor here to go down. So here's planets. We're going to go down to planets because this is what we're looking at is planets. Okay, Earth and Jupiter, whatever they might ask you in a question. Well, that's a planet question, okay? If they're asking something about bullets or guns, you go to bullets. And other things are more specific, like tension or acceleration or period or whatever. So we're going to go to planets here, press enter. And we're going to choose number 4, energy to change orbits, which is really there's finding energy to boost to a new orbit. But I can't put that all on the menu here because the screen's not wide enough, so I just give you some sort of hint of what you're supposed to choose, which would be number 4. You can press the number before it or scroll down to it. I'm going to press the number 4 here. And then, of course, other trick problems might say, well, are you on the Earth or you're on some other planet, some mystical planet, And in those cases, they'll give you the mass or the radius of the new planet or whatever. But we want to go move to a new orbit. And so we're going to choose number 2 here. I'm going to press number 2. Energy required to move an object to a different or new orbit. I put object in here because it might be a space shuttle, it might be a probe, might be a satellite, whatever the words they use. So you have to do a little bit of thinking in this class. So I give you the gravitational constant. Okay, you write that on your paper. And enter the major planet's mass, okay? So if it was another planet, we would enter that mass, but we're dealing with Earth here. And I don't say Earth here, but since they say the Hubble and Space Telescope, you can assume that it's the Earth. So we're going to press number 1. I give you the mass of the Earth. Here it is here. Without my program, you'd have to memorize that. We're going to enter the probe mass, which is 70,000. Okay. Kilograms. So we're going to press alpha first, put in 70000, press enter, and it's in kilograms already. If it wasn't, I would change it for you. We enter the major planet's radius. Well, again, we're dealing with Earth or another planet. You could enter another planet's radius, which they might hopefully give it to you, would have to give it to you to do this calculations, but we're dealing with Earth, so now I give you the radius of the Earth is 6.37 e to the 6 meters. And we're going to enter the current orbit that we want to change from, which is R1. Okay, so we have to press alpha and put in 250. And they give you what kilometers. So we got to press number 4 here to change it to meters. And I show you that you multiply times 1,000 to do that. Mark all this stuff on your paper now because you look like a genius. Looks like you really know what you're doing. And I always give you a chance to change in case you made a mistake. It's okay. Now, here's the trick. In other words, all calculations in planets are dealt with from the center of masses, center of planets, to center of satellites. But the satellite is so small compared to the Earth that it's non-existent. So the altitude is the factor. So we have to have the altitude, which is 250,000 meters, and then add the radius of the Earth here. And it comes up 6.62 e to the 6 meters, okay? So understand that R1 is equal to R1 plus the radius of the planet. Okay, now we're going to enter the new orbit, which is R2. And that's going to be 620 kilometers, so we're going to press alpha 6 2 0 kilometers again. Change it to meters. Check and see if it's okay. It says okay. And so R2 is R2 plus the radius of the Earth, which is 6.99 e to the 6 meters, okay? So now we check and see whether everything is cool. Here's G, gravitational constant. Here's the mass of the Earth. Here's the mass of the satellite. Here's the radius of the Earth. Here's the radius of the first orbit and the desired orbit next to it. Okay, so it looks pretty good. We could change it and go back and change things if we wanted to. Here's the formula. Kinetic energy now is equal to energy and is equal to work also. When they ask you to find the work done, you're finding kinetic energy, because kinetic energy is the energy to move stuff. Physically move it, okay? Potential energy is not to move things, but it's still there, depending on other stuff in physics where your potential energy is all ready to go. The energy in everything is assumed, and then it changes to kinetic energy as it moves a certain distance or whatever. So kinetic energy, and here's the formula: gravitational constant times the mass of the Earth times the mass of the satellite divided by 2 times the quantity 1 over the R1 minus 1 over the R2, okay? So we write that on our paper. Now we know the formula, which is easy if you know, but try to memorize all this stuff and do a physics exam trying to memorize this. Within 2 hours from now, you couldn't tell me the formula for this situation unless you studied it like I do every day and work on it and think about it. But who does that? You have other classes to worry about. So now we add the variables. Here's the gravitational constant, here's the mass of the Earth, here's the mass of the satellite divided by 2, and here's 1 over the R1 and 1 over R2, okay? Now we're going to multiply this just like you would on a piece of paper. You're going to multiply these 3 things together divided by 2. So that comes at 1.99 e to the 15 times 1, and then we do 1 over R1, which is here, minus 1 over R2, which is this quantity. And so that turns out to be 8 to the minus 9, and then we have so these computations are just like you would if you did it on a piece of paper. You'd have to do these computations to figure it out. Here's the answer, 1.592 e to the 7 joules, okay? Pretty neat, huh? Every step, physics.com. Go to my site, buy my program, and pass physics. Certainly is cheap enough. I can't make it any cheaper. You want me to give you the programs? Would that help, or what? A lot of work goes into this stuff. I've been doing this for 25 years, okay? So think about that. And you'll have this in your calculator forever. Throw away your physics book, throw away your notes from your teacher, throw away any material you have from your teacher gives you, but keep your calculator, keep physics programs in here, and you'll have it for life, okay? And your grandkids or whoever your friends or whoever wants to know a question about physics, you can pull out that calculator and do exactly that, okay? Same thing with calculus. And you can load calculus and physics all into the one calculator too if you want. So anyways, have a good one. Good luck with your school, okay?